You haven't noticed this. Okay. Maybe because when we're not familiar with anything, we don't pay attention to that thing. Maybe from now onwards, you keep on, like, you'll see this thing and you'll can relate it, what exactly it means. Like if it is written over there, then what does it mean? That you must have noticed in the boxes of the soaps or some liquid things or body washes and stuff like that, they mention that its pH is as per your body's pH. It's totally like it's not acidic, neither it's very basic. It's exactly as that of your body's pH. So it is not going to harm your body, okay, in that way. So let me tell you, the pH of anything represents its nature, whether it is an acid or it's a base. Now the question arises, what exactly acids and bases are and how they're different from one another, okay? So
Okay.
let's move on to this. First of all, before knowing acid bases, it is really necessary that you know about the ions, what exactly ions are, and how they relate to acids and base. So let me tell you, whenever some substances go through a reaction, okay, I mean, whenever they breaks down, so they breaks down into either they breaks down into charged bodies, okay. For example, let's say you have a molecule of H2O, that's a molecule of water. And if you break it down, you'll get two other things, that's your H positive and OH negative. Okay. So you'll get two kinds of charged particles. One of them is a positively charged and other one is negatively charged. So these positively and negatively charged particles are known as your ions. And these ions together make the stuff acidic or basic. Depends on which ion is present in a more amount or which is present in a more quantity, that is going to distinguish between the nature of the thing. Either it is going to be an acid or it is going to be a base. Okay?
Okay.
Yeah. So, um, oh wait, yeah. Let's move on to the acid then. This is the one slide which I have used on that day, like when we both were doing this topic. So yeah, first thing is acid. Now let's relate the ion concept with acid. So whenever any substance, if it's breakdowns and it gives you more of H positive ions, okay, if they gives you more of H positive ions, which we call hydrogen ions, then that particular substance is considered as acidic. Okay. Having more of H positive ions in anything represents its nature as acidic. Okay, so more the number of hydrogen ions are there, the more acidic it is. Is it clear?
Yep.
Okay. And also, like for everything, we have a measurement scale. For example, if you want to measure anything on a sheet of paper, you have scale to measure it, right? And for example, if you want to weigh your body, then we have a weighing machine. If you want to check a height, then we have a height meter to measure a height. In the same way, to measure the intensity of the substance, like how acidic it is, for that purpose, we have a pH scale that represents that how much acidic or how much basic is your substance. Like it represents the nature of the substance. Okay. So I'm going to explain about it in detail. Right now, you just write down the heading acid and then these two lines about that.
Yeah. Okay.
Yeah.
So I'm writing it.
Okay.
Okay, I wrote it down.
Okay. So, look at the example right here in the corner. See, we have a beaker and that beaker is half filled with water. So if we pass in hydrochloride gas, like hydrogen chloride gas into it, okay, we are passing in hydrogen chloride gas into the water. What happens is it breaks down into like H positive and Cl negative, like the HCl gas that breaks down into H positive and Cl negative. So because the number of H positive ions over here is more as compared to the other one, so that's the reason that the hydrochlorine gas is it's acidic in nature, and hydrogen, yeah, and HCl is a strong acid. Okay, so write down this one. You can draw this one like it's an example. Okay,
Okay.
Mohammed.
Okay.
Okay. Have you received any sort of syllabus from school?
They were supposed to send one, but I have a science lesson tomorrow, so I'll probably get
Sorry?
it then. I'll probably get it then, so tomorrow.
Okay. Because like most of the students I teach, they have received a syllabus for the upcoming exams that are going to be in the end of March. So because now we're very short of time, so maybe they would have given you, or you can ask about that.
Yeah.
Are drawing?
Yeah, I'm drawing. Mm,
Done?
yep, I done.
Okay, let's move on to yeah. Write down these three. These all are few common examples of your acids. Hydrochloric acid, that is represented as HCl, the sulfuric acid, that is represented as H2SO4, and the nitric acid, that is represented as HNO3. All the three are very common acids found in the lab. Like even if at the level of year 9, you'll get to work with these acids.
Yeah.
Once you are done with the three examples, and let me know.
Okay.
Yeah.
Okay. Okay, done.
Done?
Yep.
Okay. Next one is your bases. Okay. So whenever like any substance breaks down and it results into OH negative ions that we call as hydroxide ions, okay? Okay, whenever your substance breaks down and it gives more of hydroxide ions, in that situation, that particular substance isn't of basic in nature. Hydroxide ions, yeah, OH negative ions, okay?
Mhm.
So the more the number of hydroxide ions found in that particular substance, it indicates that like the more basic it is in nature. Okay. And also we can call bases as alkaline. Okay.
Yep.
So like whenever a substance has an extra hydroxide ions that is represented as OH negative, then we call them they are bases, and the number of OH ions present in those solution is going to represent the level of its basicity, like how basic it is. The more the hydroxide ions, it means the more basic it is. And also we call bases alkaline. Example is, this is one example that is explained, like let's say you have NaOH, and if you talk about like when it like breaks down, it gives Na positive and OH negative. So because it contains an OH negative, that's the reason that it is basic in nature. So here are some like common examples of bases. Sodium hydroxide, that's your NaOH, the one which I have represented over here. And second one is potassium hydroxide, that is KOH. And the third one is calcium hydroxide, that is CaOH twice. So that's a calcium hydroxide. So write down the bases and all the 3 points and along with the example.
Okay.
How's your preparation for other subjects going on?
All right, I guess.
Okay. And what exactly is going on in your school, like in science?
In science, um, well, we just had a test, so it's like,
Like you had a test in science in your school.
yeah, well, it was like a little test though.
So how was that?
I think it went well.
Okay. And like before your test, which subject were you doing in your school in science?
Um, well, we're doing about hormones, I think it is.
Hormones.
Yep.
Okay. It's been a very long time. I have sent you a test paper. So have you tried of attempting that paper?
I just, not really, but could we do it in like a lesson or something?
Oh, you want to do the test paper in your like session, right?
Yep.
Okay, we can plan this for the next section.
Okay.
Yep.
Okay. Yeah, I wrote this down by the way.
Okay. Let's move on to the next thing. Now, like we have got an idea about what exactly bases or and acids are and how they are different from one another, right? Let's talk about pH scale. What does it mean and where do we use it and yeah, what exactly it is. So pH scale was created to better compare the relative concentration of hydrogen ions. Okay. So why this scale was created? It was created to know the concentration of hydrogen ions in a solution. Okay. Or let's say we have any liquid thing and we want to determine how much concentrated or how much hydrogen ions are present in it. There we for that purpose, we created a pH scale. If you look at the full form of pH scale, that stands for partial hydrogen. Okay. pH stands for partial hydrogen. It's basically a kind of scale. I'm going to represent how exactly it looks like. So it's basically a kind of scale and it ranges from 0 to 14. Okay. And each step is a multiple of 10. It means like the one is, let's say you have one step and the other. So this one is going to be a 10 times more of it. Okay. So it's each step is a multiple of 10. And yeah, this is how the scale looks like. So before moving to this, just write down the heading and all the 3 points in it. Then I'm going to tell you how do we use it and yeah, how it helps in determining the nature of things.
Okay, let's
Yeah.
write it down. Okay.
I hope there won't be any change in the timetable for the upcoming sessions.
Yeah, I think so, yeah.
Okay. So are you done with all the 3 points?
Yeah.
Sure. Haven't you left any of them?
Huh?
Are you done with all the 3 points, like this one, and this
Oh,
one?
not these ones.
Sorry?
No, not these ones.
Okay. Do it and then just tell me.
Okay.
Are you done with this?
Yep, I am.
Okay, let's move. This is exactly how your pH scale looks like. Okay. As I told you, it ranges from 0 to 14. So here it is. 0, 1, 2, 3, and it goes on till 14. Okay. So what,
Should I take a photo of that?
sorry?
Should I take a photo of it?
Yeah, I can take it. Just understand it first and then you can take the photo. Okay. So this is how your pH scale looks like. It ranges from 0 to 14. What does all the numbers means over here? Okay, let me tell you. So from 1 till 6, the things are acidic in nature. Okay. From 1 to 6, all the things which are going to come between 1 and 6, they're going to be acidic in nature. Whereas the things after 8, like 8 till 14, all the things are alkaline in nature, or you can say basic in nature. The one which are 7, like the solution which represents 7, they are neutral, like they're neither acidic nor basic. So when we talk about the neutral one, then you can say the water which we drink, that is a neutral solution. How does we come to know that which solution is representing which of the number? Let me explain you that. For example, you have, see, we have a pH paper in the labs
Yeah.
that somehow look like a pale yellow or a very lightish yellow, lemon yellow kind of color. And for example, we have a solution in a beaker. So what we are going to do is we're going to take a dropper. We'll take few drops of it and we're going to pour it on the paper. And we will wait for a second. By the time you're putting some drops on the piece of that, like a pH paper, the paper is going to turn into different colors, depending on the nature of the substance which is present in that beaker. So after a few seconds, you'll get to see exactly what color is there on the pH paper. Then what you have to do is you have to take that paper and you have to compare it with the pH scale, like which color does it going to be match, or like where does it lying. It may be possible you'll not get exact same color which is there on the pH scale, but yeah, you'll get some sort of a relative color from the pH scale. Okay. For example, you took that paper and you compared it, start comparing it. And for example, you got the sea green color. Okay. So it means that the range of that thing which you're having in a beaker is between 11 and 12 because the sea green is over here. So that represents that's basic in nature because as I just told you that from 8 till 14, all the solutions are going to be your basic in nature. Whereas from 0 till 6, all of them are going to be acidic in nature. Okay? And the one which are going to be hit on 7, they are neutral. For example, if you take like on that sample, if you take the sample of water and you place few drops of water on the pH paper, and then if you look at the color, that is going to be like nil. There won't be any color. It is going to be as it was earlier. So that represents that they are neutral in nature. I mean, your water, which we drink, is neutral in nature. It contains none of the kind of ions in it. One more thing, in case of acids, the more they're closer to the 0, the more acidic they are. And same in the alkalinity, the more they're closer to the 14, the more basic they are in nature. Okay, so this is the direction, like from 6 till 0, your acidity is going to increase, whereas from 8 till 14, your basicity is going to increase. So yeah, either you can take a photograph or yeah, if you look at some examples given over here, I have taught you in topic that's acid rain. Okay, some like the first rain of the season is mostly acidic in nature because of the pollution present in the environment. So what exactly the pH could be there of acid rain? So it could range from 1 till 5. So depending on the pollution in the environment, it could range from 1, that is really acidic, till 5, like that's not very much acidic, but yeah, though it's acidic. Whereas the lemon juice, vinegar, adult fish, if it dies, then all of them have a pH of 2, 3, and which comes under acidic pH. Okay? Whereas if you look at milk, that ranges between 6 and 7, like it's almost neutral, a slightly acidic in nature because of the presence of a bacteria. And then if we look at some more like milk of magnesia, which we consume if we having some acidity problem, there we consume this liquid milk of magnesia, like our doctor prescribes us to have it. So that's basic in nature because when we suffer from acidity, what we should take is something which can neutralize the effect of acid. So that is the base thing. So that is a milk of magnesia which we consume if we are suffering from acidity. So I'll recommend you to draw it by your hand because that is going to make you remember at least one or two of them. So it will be really good if you just draw it with your hand. And yeah, along with that, you can take a like screenshot of this also.
Okay.
Yeah. Are drawing it.
Yeah.
Okay.
Okay, I drew it.
Okay, let's have an example on pH. So if you look at the urine, okay, if you remember, I told you an excretory system. I taught you an excretory system of our body. There I told you urine is a liquid that our body removes out of our body because it's a waste. Okay. So if you look at the pH of urine, that's 6. Whereas if you look at the pH of water, that is 7. So if we are saying it's 6, it means it's slightly acidic. And when I'm saying water is 7, that means it's neutral in nature. Okay.
Yeah.
So you can say that, like, if you look at the scale, here is your 6 and the next one is your 7. It means that that the urine has 10 times more hydrogen ions than water. As I told you, each one of them is a multiple of 10. So because your water is 7, it means it's 10 times, it contains 10 times lesser amount of hydrogen ions as compared to the urine. Urine has more number of hydrogen ions, and that's the reason it's slightly acidic in nature. So as soon as you're going near to the zero, they're going to become more acidic, and each of them is going to be multiplied by 10. Okay? Just write it down in the example.
Okay. Mm,
Do you keep on revising the topics which we have done?
yes.
Okay. So like whenever if you get any doubt in any of the topic which we have done previously, you can ask me.
Okay.
Are you done with this? Yes, Mohammed.
Yeah, I am.
Okay. So, yeah. When I just said that it's 7, the thing is considered as neutral, right? As I just told you, that the water is a neutral. What does it mean? Like, why it's neutral? Why it's not neither acidic nor basic? So, do you think about it? Like, why it is neutral? Well, I was expecting this thing from your side that you're going to ask me, like, below 7, everything is acidic. Okay, because they have more number of hydrogen ions. Above 7, everything is basic in nature. There's alkaline in nature because they have more of OH negative ions. Then what happens at the 7 that they neither acidic nor basic? So what happens to the ions present in those solution? I was expecting a doubt from this from your side, but it's okay. If you haven't asked anything about that, let me ask. What do you think? What actually happens to the solution at 7? That it behaves as a neutral, neither it's acidic nor basic. Yes, Mohammed.
Um,
What do you think? What happens to the solution?
would it like dissolve or something?
Then what happens to the ions if they get dissolved?
Um,
Ions are not like solid contents present in a water. They are there in the water, but you won't be able to see them. Like they're not visible actually.
uh-huh.
So what do you want to say by the term that they get dissolved? Like, can you just explain it to me?
Like um they turn into water, dissolve. Like I don't know how to explain it, but like dissolve. Uh,
That's what I want to get from your side.
evaporating, I think is the word.
Sorry?
I think is the evaporate the what?
No, that's different thing.
Mhm.
Yeah.
Mm,
Let me tell you, like when an H2O molecule breaks down, right?
right.
It gives OH plus OH negative ion. This is what we get. So it means it contains both H positive and OH negative. Then what actually happens to them? Like why it's still the water is neutral? The reason is the number of hydrogen ions and the number of hydroxide ions is equal. So the number of the many hydrogen ions are there as there are of hydroxide ions. So in this way, the charge of this H positive ion balances out the charge of the OH negative ions. And that's the reason that anything at 7 means it's neutral in nature, means it contains exactly the same number of hydrogen ions as that of the hydroxide ions. Okay?
Okay.
Yeah. So write it down.
Okay. I wrote it down, by the way.
Okay. Yeah. Let's have an overview what all we did just till now. So, yeah. So first of all, we talked about the acids, what acids are. So acids are substances that forms hydrogen ions. Okay, this is how we write it, hydrogen ions. So whenever you're going to dissolve them in water, like any substance, whenever you're going to dissolve them in water, and if they give you a hydrogen ion, like more of hydrogen ion, that represent that the particular substance is your acidic in nature. Whereas bases are hydroxides. So if you're going to mix some substances in water and you get more of hydroxide ions, that's your OH negative. So that gives an idea that the substance is basic in nature. And what can happen is your acid and base together can neutralize the effect. Okay? They can react together and can neutralize the effect. So in acid solutions, there are more H positive ions than OH negative ions. Whereas if you look at the alkaline solution, that's your basic solution, it means there are more OH negative ions than H positive ions. Okay,
Okay.
let's talk about what exactly strong or weak means in case of acids and bases. Like, how can you say that this is a strong acid or this is a strong base or that's a weak acid or that's a weak base? So, like, in what terms you're representing them as stronger or weaker? Like, are they weak in studies? So, well, that's not the thing with the acids and bases. So, then what exactly strong and base weak means over here? So, let me tell you, any acid or any base, if it dissociate completely, like if it breaks down completely, in that situation, that particular is known as a strong acid or a strong base. Now, let me tell you in a like separate way. For example, we have a solution that acidic in nature, and if we dissociate, okay, if it breaks it down and it breaks down completely, that situation we call it as strong acid. In the same way, if we have a base and if we dissociate it and it dissociates completely, okay, in that situation, that is known as your strong base. In the same way, um, if your acid do not dissociate completely or it's a partial dissociation, like something left over there which is not which does not breaks down, in that situation, that is known as your weak acid. Whereas in the case of bases, for example, we have base and that dissociates, but not fully. So something remains over there. So in that situation, that is known as weak base. So write down this strong or weak, and then the both points over here.
Uh-huh. Okay. Um.
Okay, let's talk about the physical properties of acids and base. Like, you're not going to have all this stuff from the labs all the time with you. Okay. For example, like if you're at home and you want to decide, like, is this a solution or let's say, for example, I have a bottle with me. So if I want to check the thing inside this water right now, I know that it's water and it's neutral in nature because I know that. For example, if I'm giving this task to anyone else, like you or someone else, and I'm asking them, there is some random thing inside it, and I don't know what exactly that is. And you have to determine whether it's acidic, basic, or neutral in nature. And you are not right now in a lab, you're at your home. So, in that situation, how you are going to decide whether the thing present inside this bottle is acid or a base? So, what will be your criteria to determine whether it's acid or base? So, let's talk on that topics. For example, first of all, I'm going to tell you about acids. Like if you have some acids, so what could be the precautions or what will be the like things by looking at which you can determine that it's an acid, and then with the bases. So very first is your acid. So thing first, for example, if it's an edible product, for example, the lemon, water, and stuff like that. Like if you can eat that thing, so by the taste you can determine how it is. Like either it's a base or it's an alkali. So if you're eating something, like if you taste it and if it tastes sour, okay, if anything from your house like that is eatable in nature, and if it tastes sour to you, that definitely represents that's an acid. Okay. And let me tell you, these acids are harmful to living cells. I'm not talking about the acids which we can consume, like in the form of vinegar and lemon juice. but I'm talking about the acids which are like not consumable acids. So acids are really harmful to your living cells. They can burn out the cells. And if uh, if you have aqueous solution of all the acids, that means they contain hydrogen ions, and that's the reason they are acidic in nature. And as I just told you that we have a pH paper through which we can get to know, like, is it an acid or it's a base? In the same way, we have one more kind of paper, one more kind of indicator, which we use to get to know, like, whether the things which we have is an acid or base. That's a litmus paper. Okay, that's a litmus paper. So, they are of two colors. The one is red and the other one is blue. Blue represents the base and the red represents the acid. So if you're going to pour a sample on the red litmus paper and if it remains as of red, so that means that your thing are acidic in nature. But what if the red converts into blue? That means the thing which or the sample which you have right now is basic in nature, because basic is always going to give you a blue color, whereas red is always be an indicator of acid. So that's
Yeah.
what this point is stating about. And strong acids are corrosive in nature. Yeah, you're not allowed to touch them with your bare hands. That's the reason, like in labs, you're always asked to wear gloves while handling like the bottles of the chemicals, because they don't know which, like you don't know which one of them could be so harmful that it can remove all outer, like all skin out from your body. So yeah, and one more, like you people are just because you're in year 9, and the people like the childrens of your age are quite naughty, so they're not allowed to use the concentrated products. So they are always a dilute solution for you. So write down the heading and write down the points and acids.
Okay.
Yeah.
Okay, you're done. Could I go to the toilet?
Yeah, sure. Well, we are about to leave this session, like because we are going to,
Oh,
yeah. So if you can wait for us, like a minute, that will be really great.
okay.
And if it's urgent, then you can go.
Okay. I can wait for a bit then.
Okay, okay. Yeah, let's go. I'm not going to ask you to write it down. I'm just going to explain it to you, and then you can go. Okay?
Okay.
Yeah. So the next one is the bases. So if you look at the taste, like which things you can consume, like consumable things, if they taste bitter to you, that means they're basic in nature. The soaps you have in your like bathroom, that is a base. That's the reason. Like if you touch anything and if it touch soapy to you, that means that's a base. These are the two things by like that's a physical examination of anything, and you can determine what exactly they are. Also, like if they're strong alkalis, your strong alkalis are corrosive. They can again, they can affect you because for every body, like for us, for our body, and we have a specific pH. So if it is going to get altered by any of the mean, that is going to harm your body. And again, you know that in a base, if we look at the chemical structure of it, that they are more of OH negative ions. And again, I told you one thing, that we have two papers, that litmus paper. I'm going to explain you about this in detail in the next session. That we have two types of paper, that's a red and blue. The blue represents the base and the red represents the acid. So if you have a red litmus paper and if we pour something like the sample on it, and if it converts its color into blue, that means that thing is a basic in nature. Okay?
Okay.
Yeah. I'm going to explain you this thing again to you in the next session, along with few definitions, which I want you to write it down because that are going to be really important from this section. Okay?
Okay.
And now even because you want to go and yeah, and I
Yeah.
also have one more class after this. So I hope you like the session.
Yes.
Okay. So yeah, keep
Thank
on
you,
doing.
Karen.
Sorry.
Yes, Karen.
Yeah, okay, now I can go. Bye bye, take care.
Bye.